Welcome back. In this lesson, we're going to look at stream channels. So, how water that's running off the surface of of mountains or down into valleys or across waterfalls, what happens? So, how are these water channels made? How are they maintained? What is a relatively young stream channel look like? What is an older one? What does the steepness of the bank has to do with, or the steepness of the flow of the water? What does that have to do with it? So we'll look at this and see the details. So a stream channel is a carving into the base material of the ground, usually rock, that forms a flume for water to run in. So it depends on where that water is. Is it the beginning of a stream? Is it more in the lower part of a stream? So the headwaters is the upper part of a stream. And when you have running water that's able to carve, it's going to form the bottom, usually a curved bottom of it called a channel. And all the water runs in that channel. Along the sides are the banks. So you have the bottom is the channel where the stream is, and then the banks are the sides. Now sometimes you have a very shallow channel, sometimes you have a deeper channel. It depends on the speed of the water, it depends on the amount of water, it depends on the soil that could be eaten away, and what the material of the bed is, whether it's a rock strata or soil or something like that, and how often that the water is running. So if you were to have a small stream that erodes the rock right at the very head of the stream, okay, that's called headward erosion. Let me give you a picture. So if you have water that would run down the bank of that steep cliff, and it's carving as it goes into the side of the rock, that's called headward erosion. So it's eroding, and then the head of the stream is the top of the stream. Okay, so it is possible that as that cliff is eroded by the stream, that eventually it can erode back far enough back that it could be part of a different stream, and you could end up capturing another stream. So in this picture, you've got stream A, stream B. Stream B has nothing to do with stream A. Stream A is being caused by water running down the very steep bank of this cliff, and as it runs, it can carve into it. And as it carves, that gully is going to get deeper and deeper and deeper. It is possible that at a time that it's going to actually meet up with a different stream, and you will capture that stream. It diverts the course of that river and falls into what's now looks like a little waterfall. So these stream valleys has a lot to do with the energy. So the energy of the water, what makes the water push, has a lot to do with gravity. So as it's falling down a steep slope, it's going to have a faster speed. As it goes into a more gradual slope, then it's going to have a slower speed. And so that stream slope is called the gradient. And the bottom of that gradient, where it reaches some kind of a body of water or another stream or an ocean or something like that, is its base level. So the closer it is to base level, the shallower that gradient, the slower that water moves, and the more that it's not cutting, it's dumping. So it's depositing the material that is suspended in that water rather than cutting into the new ground. Okay, so the higher it is, the more cutting power it has into the bedrock. So as you have fast water scraping against rocks over and over and over again, you can get a burrow down into the rock, even solid rock. You can get a flume. As that water speed tuckers down because it's not as steep, then you're going to have more of a time not to cut, but more to deposit. So the material that's deposited in that water, whether it's just held in the water by the turbidity of the mixing of that water, or whether it's dissolved, can sometimes deposit, and usually that deposits right at the mouth of a river, and that or at the at the mouth of a river, and that's usually where you're going to get deposits of silt, sand, and rocks, etc. Now, if you were to have a slower part of the river, so not very steep, what can happen is that as you have the fastest part of the stream normally is going to be around an outside curve. So if you're turning to the left, then that cutting water would cut into the bank on the right-hand side. If you have a right-hand turn where you're turning right, and then that fastest water is running into the bank on the left-hand side. So whatever the outside turn of a river is, the water, the fastest cutting water inside that stream normally is not just going to cut on the channel, but along the banks as well. And you can get these widenings of these curves. These curve widenings are called meanders. It usually doesn't happen when it's steep, because when you have steep running water, it'll move as straight a line as is possible. But when you have slow moving water, the fastest part of that stream is going to cut into the outside turns and make those cuts worse. So they are more distinctive, and so sometimes a meander can go back and forth, and it can go back and forth so much that it can actually cut itself, and you end up with something called an oxbow lake. We'll look at that another time. When it loses all of its speed, it dumps its material. Okay, so the first picture I have is not actually of a stream, but it's at the bottom of a mountain where you've got deposits of weathered material falling down that mountain, and it's going to fall in a fan shape. As it falls and has room to spread out, it does spread out, and you get what is called an alluvial fan. It's a depositional feature, so it's a deposit of materials that have been weathered that falls when it's very steep. You're going to get the same shape at the bottom of a river. So all that river is carrying materials, carrying salt, silt, and soil, and sand. And as it does, when it finally loses all of its power, it starts depositing this material because it can't hold it anymore. It's not moving quickly, and so it dumps it. And then it's dumping it in its own path. Because it dumps it in its own path, then the water somehow that's coming out of the river has to go somewhere, and often you are going to get these tree-like structures at a delta where you're going to have deposits, then with the rivers kind of climbing over those deposits. In the weird condition where you're going to have a drop in the level of the body of water that a river's flowing into. So let's imagine that it's flowing into the ocean and you have a drop in sea level, or it's dropping into a lake and you have the drop of a lake level. In that case, what's happening is that you can end up with a steeper part than you would have had. So in the case of this picture at the top, I've got water going into the sea level. It's very close to its baseline. You have lots of meanders. It's very slow. The slower water, you're going to get the turny back and forth and back and forth. If that sea level drops, then you end up with a waterfall, and you have a waterfall into that lake or a waterfall onto that ocean. And so if you have soft material under that waterfall, it will eventually cut a ravine and carve backwards, and so usually a waterfall always moves back. You can imagine Niagara Falls is continuously losing material off of the cliff, and that falls is actually creeping backwards as it goes. Once it does and it eats away that material, you have a steeper gradient, and you end up with a faster moving river. So what used to be a very slow moving meandering river at the top is now a quicker moving river at the bottom. That's called rejuvenation.